Good afternoon, everybody. My name is Swadling, and I'm the chair of Simulation Australasia, and it's my great pleasure to be chairing this session this afternoon on educational developments. As for all the sessions, please put your questions in the Q&A on Hoover in the box on the right, and there should be time to address those at the end. So, without any further ado, we'll get started. And our first speaker this afternoon is Guido Carim Jr. from Griffith University. Thank you, Guido.
Thank you, Philip. I'm going to just get my presentation ready. There you go. Well, thanks for having me here. I've been enjoying a lot the conference since the first time, so it's been amazing. Now, I want to present today is the we've been calling as a flight procedures lab concept. So it's something that we've been trying and developing at Griffith University with within the School of Engineering and Building Environment, more specifically the discipline of aviation. The key message that I want to transmit today is that actually it's not just about technology or simulators or simulation, but also not only also about pedagogy alone. So, but in between the two, there is a sweet spot that actually we can actually improve a lot and reinvent the way actually we train people, particularly in high hazard, high risk actually industries. So I'm going to give you like a bit of overview of the pilot training currently. So if you are very young, that's what we call like an initial pilot. So zero experience, no background whatsoever in aviation. You go to a flight school and you do what we call the ground school, just a theory. So pretty much it's around readings and slides, mostly slides, depth by slides. And then you have to do a multiple choice exam hosted by CASA, which is the regulator. And then once you finish that step, you jump on a plane and you do a little bit of practice in the simulator, in high fidelity, most of the time high fidelity simulators. But most of the time you spend you do your lessons in a real aircraft, and of course, aircraft is a little bit more expensive. Students actually can pay up to $800 an hour, and depending on the license you want to apply for, you're going to spend over 140 over between 150 to 200 hours in a simulator. So when you're ready and you do your flight test with a flight examiner, which is already 2 or 3 hours as well. The training generally is the ground school. You have one instructor per 30 up to 40 students mostly, and in the practice it's 1-to-1 or 1-to-2 max. So 1-to-2 is when you go to the simulator. And the simulators in aviation, we have like a range of different simulators, ranging from just a desktop simple we call like aircraft training device, up to the full flight simulator, which is mostly seen in airlines and big companies. And those things actually cost, I would say, between $10 and $20 million each. It's very costly to operate, to maintain, and also to buy. And in between the two, we have different levels of fidelity and costs, not only related to the acquisition, but also the operational costs. So that's why we have different categories as well. And for those actually highlighted in the blue area, those what we call certified. So which means that the higher fidelity you have in the simulator, more hours you can log in the simulator, and fewer hours you have to do in the aircraft. Well, what's the problem with the training? So training is very expensive. To be a commercial pilot, you will have to spend over $130,000 in a very short time frame. So over a year and a half most. The training is long. It's we have these huge gap between the theory, which is purely based on PowerPoints, and then you have to go in a plane and apply the theory and put in practice without any opportunity to practice or test before. We also we have seen actually previous research on pilot training, and one thing actually that stands out is a huge number of research focusing on the selection. So which means actually if you go back to the 50s and 60s, you're going to see that actually the training was designed for a very narrow range of learning styles, and mostly, of course, developed by military for the military air pilots. And because actually the tradition of aviation or aviation actually has emerged from the military tradition, so that's why we will still see these layouts and those principles being applied even nowadays. So to us, it's a very inefficient, it's resource intensive, and also it's very limited to a certain number of people who can afford the training. Simulators generally are used to replace the aircraft, rather than actually something that will add or support the training. And that's why, based on this problem, we've been trying to find a solution that we could actually enhance the pilot training and also provide more support to students. So the idea of the concept of flight procedures lab, is to introduce students to the procedural principles associated with all flight exercise and to bridge the gap between theory and practice in flight training. So the two objectives pretty much are, we're going to make the training more meaningful and also give students the opportunity to practice what we call the procedures. So which means that, for example, the sequence of actions you have to do while you're in the plane, rather than waiting to be in the plane or spend $800 in an hour to practice these or to master that particular procedure, you can actually do in a different level of fidelity simulator. And that's the idea behind the flight procedures concept. So what actually we've been trying, and this is actually the second generation of the flight procedures. We have here the Griffith. So we have, we invested a lot in high fidelity game computers. So we have the Dell Precision 3640. We also invested in a wide coverage monitor, 38 inch with an additional 23 additional monitor. The idea here is actually to be in a backpack, because also we'll be using VR headset, but not all the students actually feel comfortable using headsets. Also, we bought these two units, the flight controls. So we have these from a company in America called Honeycomb. And the good thing is these are very flexible, so we can change the aircraft model or the representation of the aircraft in that particular setting. Also, we have additional, the rudder pedals, we have additional joysticks and another throttle quadrant, so we can represent a helicopter or high or big planes or small planes, so there's a lot of flexibility. And we've been using also River G2. The good thing actually with the lab is actually we have 40 stations, fully VR capable, and also with the units and running, explaining all the software and platforms that we need to deliver the training. So what we've been trying is to have one instructor per 40 students teaching the procedures aspects of the flight. So what we did was to integrate the flight procedures lab to the Bachelor of Aviation curriculum and also the Bachelor of Aviation Management. So we now have 3 subjects that are run fully in the lab. So we call them flight procedures 1, 2, and 3. So the idea of flight procedures 1 is to train a certain sets of tasks, and 2 is a little bit different task, and 3 is a little bit more advanced tasks. And also we are also using the lab to support other subjects, like students have to learn more about aircraft systems, so we can actually hook on in a simulator and actually show how actually the systems actually react to different controls. And then also we are trying to use the lab to support the flight training. So students, they come to the lab before the flight and then after the flight lesson. So, to go through again the lesson or the scenario and try to eventually correct their mistakes. Now, in terms of the course, the flight procedures course in particular, so we've been using these 3 principles of learning teaching theories. So we've been using constructive alignment in the way that we're going to make sure that we have a very clear course objective and learning outcomes, and we align them with the assessments. So there is no learning outcomes that we can actually not assess, or no assessment that actually will not actually validate the learning outcomes. Also, we've been using instructional scaffolding, which is the second step. So once we have mapped the learning objectives and assessments, we develop the lessons and break down actually the content to more meaningful pieces where we can actually, at a bit of time, we give students, bits and pieces of that particular topic. And also we leave the lab open for students almost 24/7, so they can come and practice at their own time. The assignments generally involve the assignments actually ask the students to record themselves actually flying a particular flight or doing a particular maneuver. And so that's why we have these, we've been pretty much using these framework here to help us to develop the training focused on pilot training. So in more specific details, Flight Procedures 1, which is the course that I've been teaching and convening, the objective is for students, among the different objectives, for students to do what we call a visual circuit. So pretty much they have to take off and control the plane and follow procedures, follow some rules. They continue climbing, maintaining what we call the runway heading. Then they have to turn 90 degrees to the left, then 90 degrees to the left, 90 degrees, and come back and land again. It's one of the hardest activities and tasks that pilots have to do when they are flying right at the beginning of the training. And then what we do, we ask them to pretty much record themselves flying in the lab, in the scene, using the scene that actually we have available. They record the flight and submit. So, and then we have a markers, flight instructors, professional flight instructors marking their performance. And then we develop these marking rubric for this particular task. So we have 5 criteria, and based on that, students get their final marks for the course. And lastly, we develop also learning activities to help them with developing the skills they need. And those skills, one of the ideas was to break down a very complex task in very small and more tangible units. So the visual circuit, for example, we break down into climbing, turning, descending, controlling the takeoff, maintaining sky speed, and so forth. And we deliver 2-hour sessions per week along 12 weeks. For this particular task, students have only 4 weeks to practice and master. Most of the students, they are spending now between 5 and 10 hours a week of self-study as well. Now, in terms of the benefits and the application of the lab, we've seen actually a huge improvement in students' performance, particularly when they actually have to do the actual flight training in a real plane. We're seeing also a lot of students doing the flight training, the real training actually coming back to the lab to practice a little bit more. What we found also is that we have to move from the simulator real and to try to get all these high fidelity simulator to the simulator usage. So it's not about what you have or how much fidelity you have in the simulator, but how you use it. So we know there is a lot of limitations of using a desktop simulator, even with the VR headsets and the control yoks. We don't have what we call the force feedback. So the haptic feedback, even though it's there because of the control of the hardware, it doesn't really change if you're flying too fast or too slow, because in a real plane, if you're flying faster, of course, the controls become easier to manipulate. And if you are on the ground, it becomes a little bit harder. But also...
Sorry, 2 minutes left.
All right, cheers. Thank you, Phil. And of course, on the other end, if you just use pedagogy alone without making sure actually the technology or the medium that you are going to deliver the content through is not adequate or is not connected, or there is no synergy between the two, it doesn't really work. So as we see in aviation, we've been spending a lot of time further developing human factors and preparing beautiful slides and presentations for contents that actually students need to have a better way to visualize the consequence of acting on one control on another. So that's why we see we need actually to bridge the gap between theory and practice with combining actually good pedagogy with whatever simulator fidelity we have. And that's why we see, well, in the low fidelity simulation, we can actually use and for developing students' skills in a certain tasks, but we needed to, of course, use the right pedagogy for that. So for us, low fidelity plus modern pedagogies means more engagement. And here we have an example of a student. This student never been to a plane before, never flew even as a passenger before, and after 4 weeks, this is actually his assignment. Of course, it's a little bit technical in aviation, but I'll point some very interesting abilities. So what we can see, for example, the student is maintaining a very stable speed, which for novice and students with the experience, or particularly this one with the experience the student was presenting, is quite hard. So students also have to do procedures, so they have to change switches, they have to show us they're actually checking what they have to check, while they keep the plane actually climbing and maintaining a steady speed. And they have to turn, and they have to come back, and of course the hardest part, which is the landing, which is also those students actually are able to do. So at least the procedural aspect of the flight, we can definitely use a low fidelity to practice, but of course it doesn't replace the need for students to go and practice in a real aircraft. And we have some of the next steps. For example, we have to do like the course design validation, and also we want to see more about the effect of the VR on the students' performance, because we so far actually we done is just like analysis of the 2D environment in their performance, and that's it. So if you want to contact us, we have some contact details here. Thank you for that. Thanks, Philip.
Thanks, Guido. So we'll move on, but please put any questions that you've got in the chat, and then we'll come back to them at the end. So moving along to our next speaker, I'd like to introduce Hemal Patel, who is from the Central Coast Local Health District. And so over to you, Hemal. Yeah, can't hear you. You seem not sure if you're on mute still. The sound was working before.
Can you hear me now, guys?
Yep. Okay, that's got it.
Sorry, guys. It's currently lightning over here, so I just want to acknowledge the lands that we're all meeting on. I'm on Awabakal land, and I want to pay my respects to elders past, present, and emerging. My name is Dr. Hemal Patel, and I'm an emergency medicine staff specialist working at Wyong Hospital on the Central Coast of New South Wales. And this is a project on bringing together different disciplines in an educational environment to deal with the new challenge of transferring patients coming in from the community on a mechanical CPR device. Hence the title, bringing the team together using multidisciplinary simulation in situ to implement new technologies and procedures. A little bit about the team who can't be here to present with me. We have Amanda Blockley on the left there, who's our simulation coordinator at Wyong and a senior ED nurse. We have Graham Andrews from New South Wales Ambulance, who's an intensive care paramedic, and he has brought along our team mascot there in the picture you can see. And on the right there, we've got the wonderful Tiffany Markham, who's a clinical nurse educator and an excellent confederate in our in-situ simulation. A little bit about the hospital. You can see the Red Cross up there on the Central Coast in the top right of your screen. We're about 70 minutes north of Sydney. We see about 75,000 patients a year. We have general services, general medicine, general surgery, and some cardiology, and an 8-bed ICU. But most people who require urgent care, brain surgery, back surgery, pediatrics, have to go elsewhere in the States. And on the right there, you can see a new hospital that we've just moved into a few weeks ago, which is really great to work in a new department, and it ties into what I'm talking about later on. So a little bit of background on mechanical cardiopulmonary resuscitation devices. They've been used since 2013 in connection with multiple clinical trials. One of the ones to mention is the CHEER and 2-CHEER trials. And there's been increasing interest due to current trials going on with the RESET trials in Metro Sydney. This has led to further increase in and excitement with New South Wales ambulance stations throughout the state regarding mechanical CPR due to the benefits of having an automated device, especially during transfer of the critically sick patient, which can be quite hazardous for ambulance services in the back of ambulance service personnel in the back of an ambulance transferring these sick patients whilst performing active resuscitation. The intention of New South Wales Ambulance was to conduct an evaluation between two devices. So we have the Stryker Lucas device on the right, on the left there, and the Core Pulse mechanical CPR device on the right. And to understand the pros and cons of each and the cost benefit. And if there was any additional funding that became available, the trials of their operational evaluation would be put into, and they could use that data for wider procurement throughout the state. For our project, the New South Wales Ambulance at the time were trialing the Core Pulse device on the right, and that's what this project is built around. So this box represents the problem space, and whilst this is empty, there is no solution to our problem. And at the time when ambulance were conducting this education, our problem was, how do we transfer a patient on a mechanical CPR device safely from the community into the hospital? And one of the problems was that Wyong Hospital, where I work, has never received patients on mechanical CPR devices, and we have never had a mechanical CPR device to transition patients onto for extended resuscitation. And this is the problem space if ambulance were the only team familiar with the mechanical CPR device, which was what was happening at the time. The problem space would remain largely unfilled. And I think there was a potential for this to contribute to the wider team anxiety and function when we were receiving these patients into the hospital. A little bit of rationale and hypothesis about our project. In health, and I'm sure in other industries as well, we in health at Wyong, we've traditionally and historically trained in silos. Nursing education has normally been really short and skills-based, and normally teaching on the run style, 30 minutes here, take people off the floor or into an alternate space in the emergency department. Medical education has rarely involved training with other professionals, and even in simulation education, we have tended to take on alternate roles within a team that we wouldn't normally when the situation would present itself to us. This led to fairly poor engagement from medicine and nursing with joint and shared education. And this short, sharp education rarely met the visual, auditory, and kinesthetic needs of the learners to consolidate what they were learning in the classroom. And unfortunately, New South Wales Ambulance were really peripheral to our education, even within the hospital building, and historically have never been involved, despite us working together with them in the emergency department on a daily basis. And we kind of knew that short in-service education needed to be complemented with a multifaceted approach and purposeful practice, and to also practice how we intend to play. So we hypothesized that combined in-situ simulation with the pre-hospital and hospital teams would promote safer patient transfer in a familiar environment with a new bit of technology, improve clinical care and interdisciplinary communication in a time-pressured environment. But by bringing the team together, we predicted we could avoid a perspective blindness and start to appreciate different frames of reference and the scopes in which we all operate within. So the aim was, as I've kind of described before, is to bring that abstract classroom teaching, which was being offered at the time by New South Wales Ambulance, to somewhere where we know, we can feel, we can see, and we can work with the team we work with every day. So a little bit of background on simulation in health and in our health district. Most of the resources live at our sister/big brother hospital at Gosford, which is about half an hour south. They have the simulation labs and the facilitators down there, which rotate sometimes to Wyong to help with accreditation and other skills-based activities. We managed to procure a simulation coordinator for this project, and with the available simulation equipment at one hospital, plus the added resources from New South Wales Ambulance and the core pulse resources, we were able to formulate a plan. At the time, during the COVID pandemic, our simulation area became a storeroom, so we had to use the documented positives of in-situ simulation in health, such as test driving, foreseeing future problems, to test drive this new technology, but also try and increase buy-in through a multifaceted approach in an environment where people don't feel like they're working with outside their comfort zones or don't know where things are. We're really aware that there might be problems with cancellation when we do in-situ simulation, especially with the high patient loads that we're all experiencing in our hospitals throughout the country, really. And like with all things, there was a really simple question. I said, well, can we take a 30-minute in-situ in-service in a classroom and start purposefully practicing in an environment that we have grown to be around every day? We invited New South Wales Ambulance, and it took, as always, a few phone calls and then multiple hundred emails to make sure all the relevant parties and the relevant organizations were happy that this sort of education was being conducted. And I think with any sort of culture change or project change, a dash of persistence, I think, always beneficial. And with those resources and the multifaceted approach, we were able to design an immersive simulation in our resuscitation bay. As with most simulation activities in health, and I'm sure in other industries, there was a pre-brief, and we could not emphasize enough the importance that this was an educational experience. A simulation is still used as assessment in health, and that creates a lot of anxiety for people partaking in simulation due to the competency bases that we all work around in health. We wanted to increase clinical knowledge and the hands-on approach to looking after patients on a mechanical CPR device. The scenario designs were based around challenges including accidental extubation or failure of a accidental removal of an airway device, battery and mechanical failure of this new bit of technology, but also the transfer of care of a patient on this quite large and new bit of kit. There was a debrief conducted for about 45 minutes after a 15-minute sim, concentrating around our technical, cognitive, behavioral, and the human factors, which led to a really open atmosphere and an ability to appreciate people's different frames of reference. And then this program was evaluated by those that attended, and the results were utilized to improve and plan for future multidisciplinary simulation activities. So this is what I think our outcome became. If the box on the left represents if ambulance were just training with themselves, the problem space would be largely unfilled, and we'd have a very highly specialized group, but not filling that problem space. But I think the box on the right to us shows that with nursing, medicine, education registrars, simulation coordinators, and allied health, we were able to fill that problem space, providing multiple different perspectives on this one tiny process in patient care. And this is what it looked like. And I think we achieved our aim. Since we've conducted this activity, we have had no clinical incident reports regarding mechanical CPR from New South Wales Ambulance or within the hospital itself. There's been increased networking and stronger working relationships between all the disciplines, and we continue to do simulation regularly in our institution with ambulance, nursing, and allied health. And this has led to increasing job satisfaction. There's been massive amounts of increased buy-in. Previously, there was low buy-in, people would not come in on their days off, but from the picture, you could see there's people coming in with casual clothes to take part in this multidisciplinary teaching. And it was the beginning of an ongoing involvement to hands-on and simulation-based multidisciplinary education. And it was especially useful when we just moved to our new department. We were able to test drive a lot of the processes before we moved in and started living in this new department. And that was through a project like this, working with each other and appreciating each other.
3 minutes.
We've continued to do projects including pediatric seizures, pediatric head trauma, and we've done hybrid obstetric simulations with expectant births with New South Wales Ambulance. And this has just led to more engagement from not only the staff that are involved with patient care, but also the hospital management, especially when we get to show these projects at conferences like this. This was a really amazing book that I'm sure some of you may have read by Matthew Said, who's a British Olympian table tennis player. And I read this book after this project started. And I think at Wyong and in our institution, we're achieving what is set out in this book. I think we're having cognitive diversity in our problem solving by involving these multiple disciplines. And we are increasing our collective intelligence by learning from each other. And we're working towards providing both excellent patient care, but we're also fostering high functioning teams. I just want to say a big thank you to the Central Coast Simulation Centre for letting us use some of the resources and providing a simulation coordinator for this project. Ambulance Service New South Wales have been amazing to work with, and I've learned a lot from them, along with their education team and their health relations team, but also Central Coast Health District, where I work, who've supported our in-situ training program through this COVID pandemic. So yeah, thank you everyone for listening. And here are some references. Thank you.
Thanks, Hemal. That was great. And the teamwork side of things is a theme, breaking down silos as well. Big theme of discussions in the conference. Thank you. Thanks for that. So it's time for our next speaker, who is Kat Blake, and Kat is from the Health Education and Training Institute. So over to you, Kat.
Awesome. Thank you, Philip. I will just, oh goodness, I'm having fun with technology today. Beautiful. Let's do that. That works. Sorry, everyone. Brilliant. Excellent. Thank you, Philip, and good afternoon, everyone. Before I carry on, I'd just like to take a moment to acknowledge the traditional owners of the lands in which we're with and their ancestral spirits with gratitude and respect. I'd also like to acknowledge any members of the Aboriginal or Torres Strait Islander. We are the Rural Innovation and Learning Team for the Health Education and Training Institute. And together with HETI, we support simulation-based education and training for clinicians working in rural and remote New South Wales health facilities. Today, I'm going to talk to you about one of the programs that we've developed to support the clinical educators in rural and remote New South Wales. But I wanted to contextualise the environment in which we conduct sim and some of the unique challenges that face our learners. As Hemal just said, that some of those simulation centres aren't based with those more regional facilities in mind. And you can see from this map that this is a map of simulation centres across New South Wales, of dedicated simulation centres. And the distribution of those is located in central Sydney or in those larger, more regional areas. So for our clinicians who live and work in rural and remote New South Wales, there are specific challenges with accessing simulation-based education and training opportunities for our learners. So a lot of simulation-based education is rather infrequent and obviously makes additional challenges associated with relief of staff from already staffing poor environments and the costs associated with travelling to those locations. So the rural simulation program that we deliver is built on the principles of providing equitable access to education across rural and remote New South Wales and bridging those gaps between our rural clinicians and our metropolitan cousins. So the rural simulation program, which we run, is made up of multiple different elements that we use to support our learners. This includes some notable features such as the Mobile Simulation Centre. So that's our 4-room simulation centre that's built in the back of a 28-tonne trailer that we drag across the state to go to sites to deliver simulation education. So to help create an opportunity for sim to happen in your sites with your team. So in 2017, we undertook an evaluation of the rural simulation program, and the aim of that review was to try and understand a bit about the program and its elements and evaluate the overall experience for the learners and some of those enablers and barriers to help us inform the rollout of our program ongoingly and the effectiveness of the program that we already deliver. So we included 40 focus groups in that evaluation and interviews with over 145 individual stakeholders. We had a significant focus on both the learners, but also the educators who interfaced with the services that we were providing. Some of the specific findings that came out of our evaluation with relation to clinical educators was that those who are working in rural and remote areas are less familiar with simulation-based education as a tool. That includes elements such as developing and delivering simulation scenarios and the use of simulation equipment. And there were some barriers around how do I actually incorporate this into what I do. There was a lot of desire to use simulation in their education program, but the lack of familiarity, access to structured centres, some peer support opportunities impaired their abilities to upskill in delivering simulation activities. And debriefing in simulation was a really significant level of concern for the clinicians working in rural locations, and they wanted to improve upon those skills. So as a result, a lot of our clinical educators didn't deliver a lot of simulation education through this. So the main outcome of our evaluation relating to educators was that it was really important for us to build capability and capacity so that they could deliver simulation-based education in their facilities throughout the course of the year. So tried to then address what is it that we can do. So there are a couple of strategies that we came up with. Todd and I, as an army of two, only have a huge amount, only have so much reach. And we wanted to share our knowledge, and we want to support our educators to support our clinicians, who all at the end of the day support the patients that they care for. But we needed to build capacity and capability within those local networks and services for simulation to continue to grow. So we had two strategies that we've developed. One was the SimChat e-learning program, which we've launched onto our My Health Learning, our learning management system, and Todd presented on that yesterday, I think it was, or earlier today. The other one is the Simulation Masterclass, which is what I'm going to talk to you about now. So the aims of our Simulation Masterclass was to create this unique 2-day course designed for current and aspiring clinical educators with the idea of growing our own, to learn about how we incorporate simulation education into everyday education programs, and to give them that knowledge and skills to deliver safe as well as effective simulation-based education. Our target audience for our learners were interprofessional educators. So that includes nursing, medical and allied health, as well as paramedical learners, and other people who may have education as part of their role as well. This is a lovely group of educators from our last session that we ran in the Murrumbidgee last year, which was fantastic to get a really good group of team together. A lot of our educators work in silos and solo practice. So this is a fantastic opportunity for everyone to get together as a team to do that peer support and peer growth. For our learners, their target audience, their audience are all postgraduate students, so primarily postgraduate students, I should say. So a huge factor of the education that they deliver or focus is around patient safety and human factors and systems thinking, with skill maintenance and then some skill acquisition. So we had to actually identify what their target learning was focused on so that we could build the curriculum to help them understand how to incorporate that. So our curriculum We use the simulation cycle as the foundational framework for our 2-day program. We used a mixture of lecture and discussion-based presentations as well as group work to work our way through the simulation cycle. And at each stage, we allowed the learners to apply each of these elements in real time. So we actually included the identification of learning needs, writing a scenario, delivering a scenario, and debriefing a scenario in the 2-day program that we ran. We introduced concepts around simulation-based education and spent a lot of time exploring the why of using sim as a teaching tool and where it fits within their toolbox of strategies that they have available to them. Well, I think many of us here are going to recognise that SIM's a valuable tool. It is but one tool that we have available to us. Reinforcing the need for identifying learning needs and objectives has become a really important part of what we do within the program, not just doing a sim because you've got 15 minutes or using some equipment, but focusing on what you're trying to get out of it and then how you can come up with those strategies to meet those needs. We also introduced the importance around preparation for the learners and briefing, including some of those considerations that may be overlooked that in those ad hoc simulation scenarios that can be delivered. Debriefing from learners was a really big area of concern. So we spent a lot of time talking through varying debriefing models that were currently used. We didn't support any particular style of debriefing. We just presented many of them that are commonly used within practice and talked through the strengths and limitations of each of those and how they can apply them in what they do. We also introduced a tool that we developed called SimChat, which is part of that simulation e-learning module that we developed to practice just a way of framing debriefing. So it just gave the learners a really rounded, complete cycle and complete practice of their simulation. They each got to deliver a simulation scenario to one of their colleague groups, which is all of 5 minutes. They debriefed each other and then we debriefed them all after that, put it all together to help them to understand how it looks in real life. So the data, the outcomes of this. So we launched this in 2019, so we've only run for a few years now. Given COVID-19, some of our ability to do that has been a bit limited. So we've delivered 5 simulation masterclasses overall, but we've had over 105. We've had 105 learners, and those have been interprofessional, so nursing, allied health and paramedical. We do have a couple more planned with New South Wales Ambulance Service, as well as the Justice Health and Forensic Mental Health Network as well. So we've got some ongoing strategies and development with that. With regards to sort of the feedback that we've received from our learners, has overall been really, really positive. So our learners have all completed a participant feedback form from that, which included the Likert scale on screen from strongly agree to disagree, and it provided them an opportunity to comment on all of the program and talk about some of those elements that were really useful and how they're planning on translating that into their practice overall. They found it really valuable and particularly enhanced some of their understandings around the methodology and improving their confidence to do that. The ability to break down the sim cycle and walk through those stages was really powerful for them and allowed it to be more broken down to chunks that were digestible, but being able to practically apply them really helped the learners translate that learning. We've had from some of our learners some really interesting and positive feedback, because whilst the numbers on the page are fantastic, it's the words from our learners that are really most powerful of all, and about being able to feel motivated and encouraged to carry forward and continue doing simulation in their practice, as well as having that understanding it's not so mystifying anymore. So really fantastic feedback for us and really powerful to move forward that they're going to continue to do sim in their practice. So where to from here, and what are we going to continue to do to support our learners who are working out in these rural locations? Looking at developing and supporting the development of communities of practice so that we can continue for our isolated education faculty to actually work together as a team and to share each other's resources and time and ideas as a group, as well as maintaining and supporting those virtual connections. Talking about things like continuing to develop resource databases, to be able to share resources across locations. We all know that there's a financial impost with purchasing simulation equipment, so the use and sharing of resources throughout LHDs, local health districts, or through sites can be a really nice way of sharing that burden. We run a loan pool of simulation equipment, so that's a resource that for people, if there's a specific thing they want to do, that's something that we can also support as well. And we really just like the idea of being able to continue to share those wins and losses that we all have, what works, what doesn't work, and sometimes it's the things that don't work that are really powerful learning tools. When it comes to simulation in a post-COVID world, if anyone's got any ideas, great, that'd be fantastic. That's somewhere that we're all going to continue to adapt and grow with, but that's definitely the next hurdle that we're all going to be facing through here. So that is it, and I thank you all for your time. Some references going forward, but thank you very much.
Thanks, Kat. Great story there, and important work in the rural community, identifying the issues and addressing them. It's good to see the complete story there with the feedback loop and learning from the outcomes and moving on. And yeah, post-COVID, interesting question. we can come back to that a bit later. Just reminding everybody to put questions in the chat, but for now we'll move on. So thanks for that great presentation, Kat, and we'll turn to Maryam Kauser, who's a student at UTS. And Maryam's going to be talking about her experience in the education system in COVID.
Yeah.
Over to you, Maryam.
Thank you, Phil. I'm just trying to share the screen now. Is that all good now?
All good? Yep.
Okay, so my presentation is about how the pandemic and how education was impacted during the pandemic and how simulation helped us navigate that field. So as we moved online and as everyone was shifted to remote learning, one thing that became very apparent was that you need to use simulation to supplement this learning. You can't just tell them about what the experience might be like. Students don't get to experience the lab or practical work if they're learning from home. So simulation became very, very important in navigating the remote learning scope. And the problem statement or the problem question that I really want to focus on is, how can we move forward while holding on to the best of remote learning and teaching? There were a lot of benefits and a lot of kind of difficulties during the online learning process, but we want to see how we can hold on to the benefits as we move forward into the post-pandemic, post-COVID kind of learning environment. And before we can look at that, we want to take a look at what was already in place. Now, I study engineering at UTS, and for my degree, the university already had a lot of simulation tools in place that we could use to supplement our learning. A lot of the time, this was in using a simulator before you go to a lab. So as part of your pre-work, you would simulate, you would do some calculations, and then you create that simulated environment. So it could be a circuit, and then we create that in person and we compare the results. But moving online, we don't really have that. That in-class experience is taken away when you are shifted online. But these tools that we already had became very, very useful moving forward into a remote learning or post-pandemic, well, not post-pandemic, but rather in pandemic environment. As everyone was shifted online, as we were all moved to remote delivery, it was quite frightening because, especially for me, a lot of my subjects were hands-on, project-based. It required a lot of teamwork, a lot of lab work. And when moving online, immediately I was terrified. I was like, how am I going to complete this semester? And how are they going to let us approach these subjects when we're all studying from home? One big thing that came in handy was that they actually just broadened the application of simulation. So rather than just using a simulator as a tool to compare real life output or compare to lab outputs, there was a combination of using that simulation to design and create, and then also comparing it with like virtual lab results or virtual results. We used it a lot for modeling 3D design and seeing how that design interacts in the real world, without actually having to build it or be limited by the physical, I guess, constraints of that project. You're able to be a lot more flexible, a lot more experimental with the learning, even though you aren't able to have that in-person communication with a coordinator or a tutor or a teammate. You're still able to supplement that using the tools that the university provides us, and also the tools that are just available for free online. There's quite a lot of options with simulation. There were some difficulties. One big note, so I spoke with a lecturer at UTS, Tanya Meshet, and she mentioned that she did a research paper on how remote labs impact learning engagement. And one big thing she mentioned was that when students worked with online or virtual environments, they didn't really believe that they were learning anything. So student engagement, especially as we moved online for pandemic, became a really big problem. Students didn't feel like they were actually learning anything. A lot of my teammates, even myself, sometimes I felt like I wasn't actually gaining hands-on or applicable skills from the online learning. But then the one, I guess, flip side to that is you have a lot more flexibility and a lot more room for creativity when you have this. So as much as it felt like I'm just designing this robot that might, you know, not be possible in real life, actually using the simulation tools, I use SolidWorks a lot, and I was able to see how it would interact with different forces on it, how it would interact if it were moving along a certain path. And I think that kind of supplements that lack of engagement, and it really helped us see that, okay, you can kind of predict how your project would turn out if you had been able to do it in person. Obviously, the problems with class and interaction, you're not able to very readily ask questions or talk when you're in a Zoom class. It's a bit difficult, but we were able to have more freedom with that learning approach. And one, I want to say, very significant advantage of simulation in this scope was we were able to really see that there's more options out there than what we might originally have seen. I was able to experiment with designs and ideas that I would never have even thought about. You end up working on a level of detail with a project that you may have otherwise thought was unnecessary, or you would not even have considered it. So remote learning has those advantages, and the use of simulation has those advantages. I noticed a big difference in the learning experience of subjects that implemented simulation tools compared to those who didn't. It was very clear that, particularly for a hands-on degree like engineering, if you implement a tool for any type of simulation, be it building a circuit, testing a circuit, designing a machine, or in some cases just coding something and seeing how it would interact with hardware or embedded design, it gave us a more hands-on experience despite having to work from home or study from home. We were able to actually see, okay, this has an output. It's not just a theoretical experience. And there were some subjects that didn't quite do that. It became a very passive experience where you were just being told, okay, this is the results from the lab, figure it out. Or these are the results from the lab, and you don't really see the process behind gaining these results or how the actual lab experiment happened. And one really good way that this could be supplemented is creating a simulated tool. So UTS has virtual labs. It has had virtual labs for many years, but if you were to expand the application of this technology to more subjects and a broader scope, then you can actually really make the learning experience a bit more inclusive and a lot more accessible as well. I do feel that there is a very limited approach at present on how education is approached and how, I guess, how education is perceived. The main thing is that a lot of people assume that something is challenging or difficult because, you know, it just is that way inherently. But the comparison of how how my university experience was for the 3 years that I was studying pre-pandemic, and then now, after 2 years in online learning in this lockdown environment where I was learning remotely, I found that education can be a lot more accessible than it initially was deemed or perceived to be. You don't have to go, you know, to class to, it's like, you don't have to go on campus to learn vital things for your class. You don't have to actually fear about whether or not you're recalling everything. You have a lot more flexibility, and you also don't have to worry about what if I didn't learn enough, or what if I didn't apply the best concepts on a project, because you are able to simulate every possible idea that you could think about as you go on to that. And particularly for teamwork, having that simulation scope or having a shared kind of environment where the group can work together, it really enhances the learning experience, and it helps us kind of understand all the little details and tidbits, as I mentioned before. One big issue, however, is that while it's great to be able to simulate something and experiment with something, a lot of these tools are worked in ideal environmental situations. We've yet to see, at least in study, but obviously it's usually to keep it quite streamlined, but we've yet to see how how this system or how a device would work outside of an ideal environment. How will it interact with the world if it wasn't in this ideal simulated scope? We're basing a simulated experience off of calculations and mathematics, and it's not quite there yet where you can completely replace like in-person, real-life, practical experience. But I do feel like we're getting there as we are able to apply more and more different, I guess, situations or circumstances to the learning approach. This kind of takes me on to the next and kind of the final stage of my talk here is the future implementations. What can we do to kind of combine that accessibility and that convenience of remote learning, but also maintain how before pandemic, we used, you know, simulation tools to first have a calculated approach and then also were able to create it in person. But post-pandemic, you have a lot of restrictions. Not all labs are open. Not all labs are allowing, you know, an excessive amount of students in as they did before. How can we navigate this scope, and how can we move forward and understand that different learning styles and different learning types can be very strongly supplemented and helped a lot through simulation tools and education through simulation. It doesn't have to be just a in-person, face-to-face experience. It can be a much more immersed experience by using the technology that is available to us. That's generally it for my talk here. Another idea that I would like to leave you all with is making sure that you, if you are working towards understanding a more nuanced or more inclusive education scope, you need to understand that just because something is deemed particularly difficult doesn't mean that modern technology cannot supplement it. And it doesn't mean that modern technology cannot help students focus and I guess engage with the content better than they might in person or than they might outside of a simulated scope. It lets you experiment a lot more. It lets you understand your own, I guess, perception style and your own method of interacting with the work. You don't just end up passively working with it thinking, I expect this outcome and this outcome I get. You can say, okay, this is the tool I have. What if I mess around with this parameter or this component? And you don't usually have that kind of freedom or flexibility if you were to be working, you know, on a solid physical kind of task that's limited by your materials that are at hand or by the actual physical capabilities of the tech that you're using. You can experiment a lot more and see what's possible before you actually put in that investment and that work to build it in real life. And yeah, my main question to you is, how can we, combine that convenience, and how can we make education more accessible using simulation? And that's what I'm going to be researching more into as well. And that's about it. I finished fairly early. These are my reference lists. And yeah.
No problems with finishing early. Thanks, Maryam. That was an interesting discussion about the advantages and disadvantages of simulation and where it can be improved in the particular area that you're studying right now. So I'd be interested in more discussion on that a bit later.
Yeah, sure.
So again, please put your questions in the chat. But thanks, Maryam. We'll move on now to our next speaker. So Gaëtan Nonque is with us now, and he's from T-Reality. So over to you, Gaëtan.
Thank you, Phil. Yes, it's an early morning today. I'm calling in from Belgium. I'll share my desktop. Let me know whenever you can see the presentation or the slide deck.
It's coming through now. It's not in presentation view, but it's showing.
Very good. That's a start. Is it in full view now?
Yep, perfect.
Okay, perfect. Okay. So first of all, I'd like to thank the Australian Simulation Congress Association to have the opportunity to present the single projector visual display solution that we've developed for full immersive driving simulation. So my name is Gaëtan Nonque. I'm a product manager at Reality. And together with our partner Axiom's Edge, which is a local supplier partner in Australia, we developed the solution for the driving simulation market. So the agenda of today, we'll talk briefly about Reality, simulation visual systems, the background, how did we start off, and then we'll dig deeper into the multi-channel visual display challenges that people are typically addressed or are faced with. And then we'll talk about the design of this new visual display, single channel display solution. And then we'll highlight the components. So there are two major components, and we will go over the advantage of using a single channel display system. So our mission at Reality is to be a trusted and preferred supplier of choice for high performance simulation visual systems. This is the background. So Reality is a group of 75 people based in Belgium and also in the US. We work with local partners, and in fact, we are all originating from Barco. Barco is a company that produces projectors. And in the early 80s, the first projectors were calligraphic projectors, CRT-based projectors. And with these projectors, we helped the industry, simulation industry, with the first flight simulation on motion systems. And then in the early 2000s, we started also into the market of driving simulation. So currently we are mainly addressing flight simulation, but we are very active also in driving simulation, air traffic control, ship bridge simulation, and crane simulation. Very recently in 2015, we branded ourselves Reality because we were acquired by Estaline. And in 2017, we developed a compact dome display for entry-level markets, which is also addressing the driving simulation. Very recent this year, we were acquired by OpenGate, but our group and our team remains the same. So Triality, and in Australia, we're getting the support of Accent Edge, which Phil Revens is also in this call, following these sessions. So people have seen simulators. I think they have all witnesses these multi-channel displays, and there are numerous pictures available on the internet showing the multi-channel driving simulation. Typically, what we see is that multi-channel systems, it's not always good or easy to maintain. So over time, we can see that the blends start appearing, mismatches are visible between the channels, and this ruins, in fact, the immersive experience of driving or any kind of simulation you want to do. So in that aspect, we were looking at a solution to improve the experience for the pilot or the driver. There exists, of course, more and more automatic calibration tools, tools that help to address these issues, which is caused by drift of the projectors, also mechanical drift. And these tools are there are many tools available. They are sometimes expensive depending on the amount of channels. So if you have a very large visual display, 360 degrees experience, there could be more than 20 projectors that needs to be maintained. And so the tool can be quite expensive, or a automatic calibration tool can be expensive, and sometimes also difficult to interact or to apply. So here again, another picture showing how projectors could drift, not only in brightness, but also in colors. Although the illumination technology has quite evolved from lamp-based to LED laser phosphor illumination, still we see, our experience tells us that projectors can still drift over time. So this is one of the challenges, to make sure that you have a matched display. Then there is also the geometry alignment. So mapping the pixels onto the correct position to get an absolute geometry alignment is the important aspect. And that could be ruined also by thermal drift. So projectors heats up, mechanical structures are moving if you have a system on motion. And that is also quite a challenge. And then a third aspect is the overlaps. So in order to match two projectors on top of each other, it's important that not only geometrically you are positioning the projectors or the image as it needs to be, but also the brightness of soft edge masking is also an important point. So there exists electronical blend, but electronical blend, as you can see on the right bottom picture, this creates a very wide overlaps. So in these zones, you can see a double black. There exist techniques using hard edge or soft edge masking plates to make this uniform, but you will never get the same contrast as a native contrast. So you also ruin your image in dusk or night environments. There's also an element of losing pixels, losing resolution. Overlapping two images on top of each other also means that you're losing a resolution. So that's a waste of pixels, but also a waste of money, because you need more projectors to cover same field of view. So with all these challenges in mind, and then also looking into different markets, flight simulation, but also driving simulation, we come up with a new design using a freeform mirror. And this freeform mirror is specially developed in order to reflect each pixel of the projector to the exact location. as we've seen that projectors are increasing in resolution, increasing in brightness, we can use these pixels more efficiently using a freeform mirror, and then with the shape, make sure that the pixels are positioned onto the right place onto the screen. There exists several ways of designing a freeform mirror, but we chosen the vector-based solution, and I'm not going to very specific or in detail. I think if there's questions about it, I'll answer them after the presentation, or you can contact me, of course, for more information. But in general, we have applied numerous and quite large amounts of points in order to map and correctly create this shape. And it allows for true freeform surfaces. So there's a high computing machine calculating all the dots, all the pixel positions, and then it generates this shape in order to produce a very uniform, nice shape of mirror. So that's in fact the challenge. So it didn't exist. So we really had to investigate all the methods and also do test setups in order to evaluate how you can ideally do pixel mapping onto the screen surface. In order to do that, there's calculations behind it, but there's also a need of a tool, a design tool that can predict performances. So in the center, you can see a sort of exploded view of the main components. So you have the projector with the freeform mirror, and then there's a screen, a seamless freeform screen as well, that is mapping according to the freeform mirror. And so in order to predict image performance, you need the correct projector and lens characteristics. And then you do an evaluation, and you do a test setup, and you close the loop. You evaluate the performance, and you readjust the settings to create this freeform shape. And multiple loops are needed, and we call this a closed loop design. And with this triality property SimCut design tool based on lens and projector characteristics, we can then also look at resolution performance, the uniformity of your pixels onto the screen, and evaluate brightness and contrast. So there are calculations in that tool that really can predict the performances. And for our design and our test case, we used an 8K E-shift projector, which is currently the highest resolution projector available on the market. It almost has 8K, so that's 8,000 pixels wide and 3,000 to 4,000 pixels in vertical direction. And with this freeform mirror, you really can map all these pixels onto the screen, which is a 210 degrees horizontal field of view, seamless screen, up to 45 degrees field of view. With this high resolution projector, you can go up to 3 arc minutes per optical line pair. And that's, if you don't know the term arc minutes per optical line pair, knowing that 2 arc minutes per optical line pair is eye limited resolution, it really has a very good resolution for simulation. By applying screen coatings, we can also adjust brightness and contrast. I have a slide later on that explains more in detail what we've done. So the system components, there are 2 slides talking about the 2 major components. One is, of course, the freeform mirror. So the shape really guarantees perfect pixel mapping, and that's important for having or using all the pixels, but also for uniformly spreading the pixels onto your image. And the design allows for several projector options. So you don't necessarily need an 8K E-shift. You can also use a different kind of projector, more entry-level type of projector, 2K like HD, or even a wide XGA resolution. So different resolution is possible as long as the lens characteristics, so mainly the throw ratio, remains the same of the projector. So that's the critical element of the calculations that has to remain the same. So on the right, you can see our prototype test case. You can see the bottom picture on the right is the image onto the freeform mirror, which is then reflecting the image onto the back projection screen, which is the primary screen, which you can see here. And that's our second major component. And of course, when you develop such a display, you want to have a seamless screen. And this 1.75 meter radius screen has been produced by using a thermoform or single mold technique, which allows really to create 210 degrees by 45 degrees vertical field of view without any seams. A second aspect, in order to have a good image performance, is the coating itself. So we use a low screen gain coating, which is 0.2. But you can also go higher if you need more brightness. But after resolution, contrast is the most critical element in the display. So we typically go to a lower 0.2 gain in order to improve contrast and have also your content better visualized. So there's better view of details with a higher contrast. So the coating is applied by the use of a robot, and this also guarantees a uniform brightness on the entire screen. So what are now the advantages versus legacy technologies or multi-channel technologies? It's first of all image stability. So the use of a single projector creating such a large field of view really helps the stability and also then of course doesn't require many maintenance. So there's no need for automatic calibration or people to adjust over time the visual display.
2 minutes.
Okay, that will work. So maximize the image performance. So again, pixel mapping helps with that. So utilizing the full pixel and brightness is an element, but of course there's no overlap, so you don't waste any pixels. And then you have the full seamless vertical vision, which I already mentioned, that this single piece molded screen really creates an immersive feeling. There's no reference anymore onto the screen, which of course is an important element to really feel fully immersed. And obviously, when you have a single projector display, you also reduce the installation time. So not only in maintenance, but the installation times go much quicker. So you can set up remote locations very fast, and that can be very helpful in some cases. Some additional benefits, and I'll close. That's a closing slide. It's a small footprint, so the projector is fully inside the screen, so there's no projectors in the peripheral side position, which you typically have when you have 3-channel type of projector display, which would cover then this 210 degrees field of view. There's also the constant eye relief, so this pilot is in the center and the radius is constant, and it's future-proof, meaning that you can increase or change the projector and increase your resolution, increase your brightness. So it can be tailored to whatever requirement is necessary. And that was the closing slide. So if there's any questions, I'm happy to answer those.
Perfect. Thanks for that, and thanks for getting up so early in the morning. I think it's just gone 20 past 6 in
yes,
in Belgium right now. So
correct. It's a bit early, but okay. So for once, I'm glad I have the opportunity to present this solution.
So a quick question I had, while people are putting questions in the chat, of course, because there's, I'm sure, plenty of questions for all our speakers. We've got 10 minutes. Is the size of the screen? What kind of limit is there on the size of dome? You mentioned, I think it was a 1.75 meter radius, but how big can it go and still achieve reasonable results with an 8K projector, for example?
Yeah, indeed. So so this design, indeed, we've started with a screen that was, in fact, developed for another type of market. So typically flight simulation, where we believe that 1.75 meter is ergonomically a very good fit for the pilot. And so we really started with this design. Of course, it can be tailored. Its size can be increased or even going lower, but that would, of course, require some NRE, so non-recurrent engineering costs in order to optimize for the size you require. So you can imagine if you would have a truck where a pilot or two drivers are sitting next to each other, or two people sitting next to each other, you would require a larger radius and a larger field of view. So as I mentioned, the idea, the concept has been proven, so it can be tailored. Of course, there is some more engineering required. But in terms of performance, again, projectors are increasing into resolution, increasing in brightness. So as long as the lens throw ratio of a projector is similar, yeah, this system can be tailored.
Great, thanks for that. Thank you. So I'll keep on moving because there are no more questions. So I might actually move back to Maryam and just wonder if you could maybe comment a bit on how simulation and the simulation that you've seen being used can improve accessibility for engineering students.
Well, the first thing to note is while engineering and universities in general focus a lot on inclusivity and diversity in their courses and degrees, a lot of the time that seems to be limited to largely to race and gender. And one big aspect of inclusivity, particularly for the educational field, is the students who are not able to interact well with the content. So this is for those who have disabilities, students who have, mental health problems, or those who maybe struggle with a learning disability. We need to take into account how these students interact with the work. One big problem that I've noticed with engineering education is that the way that it was delivered, particularly when delivered online and in person, is that it wasn't very accessible for students who weren't able to immediately pick up on the concepts, or who weren't able to learn from the, I guess, the default mode of delivery. And my idea is that we can use simulation tools, and with how accessible simulation tools can be, they can be made to, adapt, or they can be adjusted to suit any particular learning style. Then we can use these tools to actually create a more immersive and cohesive learning experience for students. We don't want to just have a student feel like they are incapable or unable to complete a course, or unable to, I guess, interact with that content just because of that mode of delivery. And simulation can actually be used very, very strongly to make it so that students can, I guess, as I mentioned before, with the flexibility aspect of simulation tools and learning, we can also make it so that there's alternative ways to actually interact and receive that information that they are learning, and gain the, I guess, the vital education that they actually need to progress. Yeah.
Great. Yeah, thanks for that. We obviously, diversity and inclusion was a big topic yesterday and has been throughout the conference. So the ability to use simulation to improve access for everybody, I think, is great to see. Okay, so Kat, I was just wondering if you could maybe comment. I mean, obviously, rural healthcare is an important topic. In terms of the way that simulation is used and the lessons that you learned from what you took us through, what do you see happening next? A similar kind of question, I guess, accessibility.
Yeah. I think so. The greatest challenge is, time. Is in simulation in healthcare is always going to be the greatest challenge for people sort of performing simulation out there and working with the learners. So a lot of it's around trying to actually just build a critical mass of people who understand how to use sim, and to try and break down some of those existing barriers that that we sort of feel like may be there, whether they're realistically there or not. So around a lot of the common things I have is, I don't have that equipment, so I can't do sim. So really trying to get people back to the basics of what is simulation and how do you use it, and how can you take it away from, I don't have a big fancy sim center, I don't have this big fancy equipment, all I've got is me. So we take down some of that, we call it sim on a shoestring. How do we do sim in a world with no money and without stuff, without time? So that's the reality of sim in health. So that's sort of the approach that we kind of take, because if you do only have 15 minutes to do a simulation, it doesn't mean that it can't be a really powerful learning opportunity, but to help people understand just the hows of being able to translate that is probably the thing that we really want to focus on, and building those communities of practice and that interconnectedness for those silo isolated practitioners is a really important element of that.
Yeah, absolutely. And question for Hemal, you talked about change management as being important. As a result of the work that you described for us, which was, as I said before, a really nice complete package, did you see the impact of that from a point of view of acceptability and willingness to try those kinds of approaches more in the future?
We definitely did, from the different kind of silos. So I found it really strange that we didn't actually work with ambulance in education. I found it just a really strange thing. I've not been around the block that long, so I think I've got a lot of corporate knowledge to kind of still build, but there has been change in, like, where with the biggest thing was when we moved into a new department, like that brand new hospital, like we were simulating, we're so willing to just get on the phone and go, do you want to come do this with us? And they were like, yeah, sounds great. There was no real barriers after that first kind of perceived hurdle of, oh no, we can't do this. They were like, but I think that was basically just, we didn't understand frames of reference, but we just continued to work together, and we're now moving to working with utilizing new ambulance protocols. So they're using basically external cardiac pacing now pre-hospital, and how we transition their pre-hospital to hospital, just with what was started by a very simple question. Maybe we should just try this in our workspace. But maybe I'm naive, and that's what made it easier.
Sometimes not knowing things is better, isn't it? And as you said before, persistence is often the key. Yeah, thanks for that. Yeah. I think there's time for one more question, and I'm going to ask it because there's nothing on the chat or the Q&A. So for Guido this time, in your presentation, you talked about the use of simulation in training pilots. And just in terms of your experience looking at the different approaches and the amount of time that simulation can be used, are you seeing any benefits in the quality of the trainees that are coming out the other end? Often these people are going to airlines, regional airlines, or other jobs. So are you getting any feedback from that perspective about the training outcomes that you're achieving?
Yeah, we had a recent cohort who have been through one of the courses we offer, and are now finalizing their flight training and starting their training with an airline. Actually, the airline has a very positive feedback to us, and they said actually students were had a little better knowledge of the the foundations and the fundamentals of a couple of subjects, but also they tried to adapt actually what their experience using those desktop simulators to their corporate world. So, which means that airlines are still based on high fidelity, very expensive simulators. So there is no space for you to practice before you hook on one of these, big toys. So what the students actually doing, they're actually buying their own simulator, their own, joysticks and the controls, and then practicing at home using the manuals and the procedures described on the manuals. And the chief pilot, actually one of the companies, said, "Look, that's a very interesting thing. So they are now trying to adapt what the students have been doing there as part of their formal training process as well."
Okay, fantastic. Great to hear. So time to move on to the next session now. I'd just like to quickly thank all our speakers for taking the time to present to us today. It's been great hearing all those different stories. Lots of common themes and also some quite different topics. So thanks again, and thanks for attending, and see you in the next session.